Erika here with PrepScholar GMAT. Today we're going to do an introductory lesson on one of the most challenging problem types on the GMAT, data sufficiency. Now, this is going to be a pretty long video, so I've gone ahead and created an agenda for the topics we're going to cover today. If you look in the description, there are timestamps for each of the topics in this agenda. So, for example, if you already feel comfortable with the concept of sufficiency, but aren't totally clear on how these questions are relevant to business school, you can click on the timestamp for what's the point of data sufficiency and skip to that portion of the video. But for now, we're just going to go ahead and start right at the top with an overview of GMAT Quant. So the GMAT Quant section is 75 minutes and 37 questions in total. Now, these 37 questions are going to be split between two different types of quant questions. Now, the majority of these questions are going to be problem solving, and problem solving questions look like this example. Now, if this looks familiar to you, good. That means you've been paying attention since elementary school. This type of question is on pretty much every standardized test that involves math. There are multiple choice questions. There are 5 answer options, and only one of them is correct. And to get to that answer, we look at the math problem in the question stem, and we solve for the answer. So to solve the question, we solve the problem. Pretty straightforward. Now, the rest of the problems on the quant section are a little bit different. They are these data sufficiency questions. Now, in data sufficiency, we have this question stem that isn't enough to solve the problem. Then we have these statements that provide a little more information. And then these answer choices ask us not what's the answer to the problem, but rather, can we solve the problem? So to answer the question, we don't answer the problem. We just say we can or can't answer the problem. So this is pretty weird. This isn't something that shows up on other tests, and that scares a lot of students. This isn't something they've done for years and years and years and is comfortable. However, these might actually be your new best friend. Data sufficiency questions provide a lot of opportunities to solve, a lot of tricks, a lot of new strategies that you can't actually use on these problem-solving questions. So data sufficiency can be a huge ticket to a good quant score. And this is especially true because data sufficiency questions make up at least 1/3 of the quant section. We've actually seen that in the past years, the number of data sufficiency questions on the quant section has been increasing. So at this point, up to 1/2 of the questions on your quant section might be data sufficiency. So again, just another reason why this question type is really important to feel comfortable with and to have totally locked down. So now that we've looked at the quant section as a whole, let's start looking a little bit more closely in at these data sufficiency questions and their structure. So one thing to note just right off the top is that these data sufficiency questions are going to be interspersed with problem-solving questions on the quant section. So it's not like you get all of your problem-solving questions up front and then all of your data sufficiency questions. You might, for instance, get one problem solving, one data sufficiency, one problem solving, one data sufficiency. But you might also get 7 data sufficiency in a row and then not see a single one for 10 questions. It's going to be totally dependent on how you're doing on the test that day. Now, the structure of the data sufficiency questions we can kind of break up into 3 different parts. Now, the first part of the question is pretty familiar. This is the question stem. We've got one of those on problem solving as well. Now, the difference here is that the question stem on data sufficiency questions is never going to be enough information to solve the problem. So in this example, our problem is, does S contain more integers than T? We are not going to be able to solve that with the question stem alone. We're going to need more information. Now, that information may or may not be contained in the 2 statements below. So there's always going to be 2 statements, and they're going to change with every problem. So the question stem changes, and the 2 statements change. And whether or not those statements are sufficient to solve the problem will also change. But one thing that's always going to stay consistent between all data sufficiency problems is that those statements are never in question. We're never questioning whether or not they're true. They're never ever going to contradict each other or the question stem. So we're never going to ask ourselves, well, is statement 2, is that really possible? It is. It always will be. If we think that it's not true, we're reading the question wrong. We're asking whether or not it provides extra information that helps us solve the problem. So the two statements should never contradict each other. So if you're actually finding that they don't work together, that's a good clue that something has gone wrong in your math. Now, the last part of these data sufficiency questions is those answer choices. Now, while the question stem changes and the two statements change, those 5 answer choices will never, ever change. They're always going to be the same, always the same phrasing, and always the same order. So it's a really good idea to memorize these so that if you go, okay, statement 2 is sufficient, but statement 1 is also sufficient, okay, which answer choice is that? You never have to do that. You never have to look for which answer choice is correct. You just know right off the top of your head, oh, that's D. And so you don't have to waste any time with that sort of thing that you can just rote memorize right now. Now, those 5 answer choices deal with the concept of sufficiency. But what does that mean? What does it mean for a statement to be sufficient to answer the question? On the GMAT, the concept of sufficiency is defined as having enough information to reach one and only one answer. Now, this concept of one and only one is critical. So if we reach 2 possible answers, it is not sufficient. So there are 2 different types of data sufficiency questions, and what sufficient means varies a little bit depending on which type of question we have. So the first type of question is a value question. And in a value question, our problem is going to ask for a value or a number. Pretty simple. So here we have what is the value of x. So we want to be able to find one value for x. So that value might be something like 5, or it could be something like 7.8, or it might be something like a plus b over 2y. But it's one value, and it can't be anything else. So if we were to solve this problem and we get x equals 5, and it cannot equal any other number, then that is sufficient. We are able to solve using the information we have. But say with statement 1, we determine x is greater than 5. Well, that means x can be 5, it can be 6, it can be 8.2. That's not enough information to solve, so that is insufficient. Or if we determine x can be 5 or 3, again, that's 2 answers. That's not enough for one and only one answer. So that would, again, be insufficient. Now, our other type of problem is a little bit weirder. We have also yes-no questions. So let's look at this example for a little clarity on what that is. So here we have, in the xy plane, does the line with the equation y equals 3x plus 2 contain the point RS? So we see that we're not looking for a number. We're not looking for, oh, r is equal to 5 and s is equal to 2. No, we're looking for an answer of yes, no, or maybe, right? So if we're able to determine the line with equation y equals 3x plus 2 does contain the point RS, there's no way it does not, that's sufficient. But one thing to keep in mind is that if we answer no, there is no way that the line with equation y equals 3x plus 2 contains the point RS, that is also sufficient because we were able to answer that question with a definitive answer. So whether or not we answer yes or no, that's still sufficient. Now, the one thing that's not sufficient is if we go, maybe. So if we determine, okay, most of the time, the line with equation y equals 3x plus 2 contains the point RS, but sometimes if this one thing happens, then no, it won't contain the point. Well, that's insufficient to answer the question. We cannot give one and only one definitive yes or no answer. So with these 2 different types of questions, we're going to reach one and only one answer. But for value questions, it's going to be one and only one value. And for yes-no questions, it's going to be one and only one yes or no. All right, So now that we understand what a data sufficiency question is, what sufficiency means, what these problems look like, let's think for a second about what is the point. A lot of students really don't like to study for these questions because they're unfamiliar and they don't see any real reason for them to exist. You can test math just fine with problem-solving questions. We've done it for years, so why not just keep doing that? The point of data sufficiency is, in part, to test those math skills, but it also tests business skills that are going to be absolutely critical both in business school and in your career afterward. So a couple of the main points here are that data sufficiency helps you to determine the value of information in making decisions. So on data sufficiency questions, we're evaluating whether or not these statements provide information that's helpful to us in making these decisions. Is it enough information? Do we still need more information? Is this totally irrelevant? Things like that. Now, this can be applied in the business world to determining what information is necessary for you to make business decisions. So determining, okay, maybe we're not going to make a decision until we gather more customer data, or going, we have enough information now, let's not waste any more time doing more and more research. Let's go ahead and make that call at this point. So that's actually a really critical skill that is tested with these math problems. Pretty weird. A secondary element here is avoiding and testing your assumptions. And we'll talk a little bit more about this as we get into how you can make assumptions on these data sufficiency questions, but avoiding assumptions is critical in the business world. It's really, really common for people to assume that they know what their stakeholders or their clients want. Just like on these data sufficiency problems, it's really easy to assume some things about your answer that may not actually be true. So one of the things that data sufficiency questions test is whether or not you can critically analyze your own thinking and go, what kinds of assumptions am I making? And are those actually supported by the problem? Or can I find edge cases where these things are not actually true? So data sufficiency is actually a lot like the quantitative section's critical reasoning. So it takes skills that you already have and that are already being tested elsewhere in the section. So critical reasoning tests a lot of the same skills as reading comprehension, just like data sufficiency tests a lot of the same skills as problem solving. But it kind of adds that extra business element on top of that. We're taking that and expanding that and doing more critical thinking on top of it. So data sufficiency is not only important to your GMAT score, but also important to your success in business school and in your career beyond that. So this is why this matters to business schools and why it's on the GMAT. So how do we approach these questions to show business schools that we can do it? So we approach data sufficiency questions roughly linearly, not entirely though. We're going to start at the top with the question stem. Now, a lot of people go, okay, I am evaluating those statements. So the statements are the most important thing for me to look at. And they kind of skim through that question stem and go, oh, it's fine, I got it. That's a really bad idea. The question stem is really known for putting in tiny and key elements of information just kind of slipped in there, and they're meant to kind of trip you up. So if you miss that key piece of information, you're gonna get this question wrong. So let's look at an example of where there's a key piece of information in that question stem that is pivotal to getting this question right. So here we've got, is the average or arithmetic mean of 5 different positive integers at least 30? Now here we actually have 3 key pieces of information. We have different, positive, and integers. Now, if we look at statement 1, each of the integers is a multiple of 10. If we miss the word different, we're going to think that this is not sufficient. If we miss the word positive, we're going to think this is not sufficient. Only with all of those pieces of information is this statement sufficient. Same with statement 2. If we miss different, positive, or integers, this statement is not going to be sufficient. So those tiny little words are actually going to be pivotal to getting this question right. And oftentimes test makers will build these in so that they trap you. And they're often really small. So things like x is greater than 0, or y doesn't equal 2, or the slope of the line is negative, or b is not an integer, something like that. So be really careful that you're noticing all of the pieces of information that they do give you in the question stem. It's not going to be sufficient to solve the question, but it's going to be important to solving the question. Another thing to think about here is not just what is there, but what isn't there. And this is where those assumptions kind of come into play. So let's look at this problem as an example. So we see that our question stem is really, really short, doesn't give us a lot. Is x less than 20? All right, let's look at statement 1. The sum of x and y is less than 20. So what we're meant to think here is go, okay, if x plus y is less than 20, this means that both x and y must also be less than 20. So for instance, x is 18, y is 1, x is still less than 20. Perfect, awesome, sufficient. Well, what if y is negative? Well, then we could have something like x is 25 and y is negative 6, and then x plus y is 19, which is less than 20. And here, x is actually going to be greater than 20, so this statement is actually insufficient. But we only are able to figure that out if we realize that x and y could also be negative. The problem never tells us anywhere that they are positive. So this is an example of an assumption that's really, really easy to make. And common assumptions are things like thinking that a number is positive or that a number is an integer or something like that. So be really careful with those question stems to not only notice what is there, but also to take note of what isn't there and what kinds of edge cases we might have that could make these statements insufficient. Once we've gone through the question stem and gathered all of our data, maybe even writing down some of those pivotal pieces of information on our scratch paper, we're going to go in and look at those statements. Now this is where our order can get a little funky. We're going to start with the easiest statement and then make our way to the harder statement. So sometimes the easiest statement will be statement 1, but sometimes it'll be statement 2. So we might go out of order on these. Now, how do we determine which one's the easiest? Well, oftentimes it's just the length. So in this example, we see that statement 1 is much shorter than statement 2. So that's just going to mean statement 1 is going to be a lot easier to read, right? So we might just go with that one based on that alone. If we look a little bit closer, we see that statement 1 gives us a number, just a value. In 1970, the population of City K was 160,000. Easy, right? But statement 2, we see it gives us 2 different pieces of information, and those pieces of information involve percents rather than actual values. So it's actually much more complicated. So we're going to start with statement 1, evaluate that one, and then move on to statement 2. And then if we need to, we'll then put them together. Now, why do we start with the easiest statement? We want to get to both of them, right? Why proceed through them in any order? This is important because of the process of elimination. Now, sometimes you're going to run out of time on a problem, or sometimes you'll find that one statement you can solve and maybe the harder one you can't. So it's actually really important to think about maximizing your chances on these problems. So doing what you can for sure do first, what's easiest, and then seeing if you can do the rest. So for instance, if we were to go through statement 1 and find that it is sufficient, we can actually go through and eliminate 3 of our answer options. So A, statement 1 alone is sufficient, but statement 2 alone is not sufficient. Well, that's possible. We don't know anything about statement 2 yet, so we'll leave that one. Number 2 says that statement 1 alone is not sufficient, but we know that's not true. It is sufficient, so we can eliminate that. Statement 3 says neither statement alone answer choice C says that neither statement alone is sufficient. Again, not true. Statement 1 is sufficient. Eliminate. D is possible. It could be that statement 2 alone is sufficient as well as statement 1 alone, so we'll leave that. And then the last one we can eliminate because we know statement 1 is sufficient on its own. We don't even need statement 2. So they'd definitely be sufficient together because we can solve it alone with just statement 1. So we can actually go through and eliminate 3 answer options. It's also the same for statement 2. We just switch and eliminate answer choice A rather than answer choice B. Now, if we find that statement 1 or statement 2 is insufficient, it's a little bit less help, but we can still eliminate 2 answer options. So again, which ones we eliminate will depend on which statement it is that we've evaluated. So what we see here is that by evaluating even one statement, no matter if we determine if it's sufficient or insufficient, we can actually eliminate quite a few answer options, at least 2. So this means that even if we totally hit a wall on that second statement, or the first statement as the case may be, we still have a really good chance of getting that problem right even if we totally guess. So going through and starting with the easiest statement helps us a lot with this process of elimination. So just like we memorize those answer options, it's a really good idea to memorize what this process of elimination is. This is something you can just know. So if, for instance, you go, okay, statement 2 is insufficient, which ones can I eliminate? You should be able to know right away which statements you can just cross off. You don't have to waste any of your precious time on that test thinking about that. You can save all of your time for actually going through and evaluating the next statement. So do yourself a favor and lock that down right away. All right, so we've walked through how we approach these problems in general, but what more specific strategies can we use? So we're going to cover 4 of the most important strategies that we can use on data sufficiency. So the first strategy is actually kind of more of a mantra, and this is something to think about as you're going through your practice problems and as you're sitting down on test day, and that's don't do more than you need to. Data sufficiency problems ask you to figure out if you can solve the problem. That often means that you don't actually need to solve the problem. So this means that a lot of times you don't actually need to do a lot of math. And that's critical to saving a lot of time. So let's look at this example. So this question says, a certain one-day seminar consisted of a morning session and an afternoon session. If each of the 128 people attending the seminar attended at least one of the 2 sessions, how many of the people attended the morning session only? Makes sense. So there's 128 people. Some attend only the morning session, some attend only the afternoon session, and some attend both. So let's pretend that either we decided to go for statement 2 first or that we've already dealt with statement 1. We're just going to look at statement 2. 7/8 of the people attended the afternoon session. Okay, so if 7/8 of the people attended the afternoon session, this means that that includes the people who attended the afternoon session only and the people who attended both afternoon and morning. All combined equals 7/8. So that leaves 1/8 of the 128 people. Who are they if they didn't attend the afternoon session at all? That means they must have only attended the morning session. So we know 1/8 of the people attended the morning session only. So if we just stop at this point, we go, okay, at this point, I can take 1/8 of 128, and I know how many people attended only the morning session. Do I actually need to take 1/8 of 128? No, it doesn't change my answer at all. I can solve, and I know that. So I don't actually need to go in and do any math. I just need to use logic. So at this point, depending on how fast you are at doing fractions, you might save 10 to 30 seconds here. But on a lot of problems, not doing more than you need to can save you multiple minutes. And on a quant section where time is a really huge factor, this matters a lot. So when you're on the data sufficiency section, it's really important to continue to think about, when do I have enough to solve the problem and how do I stop there? All right. Strategy number 2 is to simplify. Now, one of the key ways that we can simplify is using algebraic manipulation. So what does this mean? This means that if you are given an algebraic expression, oftentimes you can turn that into something else that's going to be more useful for you. So let's look at an example. So we've seen this problem before, actually. So this one says, in the xy plane, does the line with the equation y equals 3x plus 2 contain the point RS? And then we get these statements that have these awful equations in them. Now, a lot of folks are going to go, okay, I need to expand these statements. I need to go 3r times 4r, then 3r times 9. 3r times negative s, 2 times 4r, blah, 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 blah. That's going to take a really, really long time. So let's actually kind of rewind and go back to our statement. We see y equals 3x plus 2. Now 3x plus 2, that looks a lot like 3r plus 2, which is in both of our statements. So what can I do to maybe turn that into what I see in the statements? Well, if y equals 3x plus 2 contains the point rs, that means I should be able to plug in r for x and s for y, and that statement should still be true. So that would give us s equals 3r plus 2. If we move all of that to one side, we end up with 3r plus 2 minus s equals 0, which is actually, we see that in our statements, right? So what we can actually do here is then we can think about these statements logically, thinking about 3r plus 2 minus s as a 0 of these equations. And if y equals 3x plus 2 contains the point rs, then 3r plus 2 minus s must be a 0, right? So we need to then go in and look at each of these statements individually and determine, is that for sure a 0 of this equation? So there are also other ways that we can simplify. So if we don't have algebra to manipulate here, we might also build equations. Now this is absolutely critical in problems that deal with word problems, right? So if we're given a bunch of words, a bunch of sentences that contain math, we're going to actually want to translate that English into math that we can then use on our own paper, plug values into, maybe manipulate further. And that helps us to do work on our scratch paper rather than doing it all in our head. Another thing here that we can do to simplify is to make diagrams. And this is especially important on problems like that deal with geometry or that deal with graphs. Oftentimes these problems don't give you diagrams on the test. If you're not given a diagram for something that's a visual problem, you definitely want to make it yourself. Even if you are given a diagram, it can be really helpful to recreate that diagram on your scratch paper so you can label it, manipulate it, move it around, so you can more easily solve that problem. Similarly, if you're dealing with, say, an overlapping sets problem or something that deals with organizing a lot of information, doing something like building a double matrix or a Venn diagram can help you to keep that information straight and to more easily figure out how it relates to each other. So when you're given something complicated in a problem, almost always you're going to be able to find a way to simplify it. So whether that's through manipulating the different variables, by building equations, or by making diagrams, find a way to make this simpler. Because if something seems overly complicated on a data sufficiency problem, there's probably a trick. All right. Now, the third strategy is actually kind of more of a prioritization process. So when you're solving data sufficiency problems, there are ways to solve it that are good, and then there are ways to solve it that are really good and really efficient. So in general, in data sufficiency, it's a really good idea to rely on logic right off the bat. Logic is going to be the way that you can get to answers the fastest. So relying on your understanding of number sense, relying on your understanding of a scenario will help you get to the answers most efficiently. So data sufficiency tests critical thinking. So whenever you can use critical thinking to solve the problem, the faster you're going to get through it. Now, if you aren't able to kind of work through to an answer in your head, relying on hard math is going to be your second best option. So going through, building those equations, and then solving until you get to a number is going to help you out as well. That's your second best. And then your last resort, if you don't know how to create the equations that you want, if you don't know how to use logic to get to your answer, is to pick smart numbers. And what that means is pick numbers that you're pretty sure are going to prove that your statement is insufficient. Now, this is a last resort strategy because if you pick the wrong numbers, you might get the wrong answer. So oftentimes you'll have a statement that is true for maybe every single value except for two different values. And if you don't pick those two values to plug into your equation, you're going to get the wrong answer. You're going to think that it's sufficient. So picking smart numbers should be a last resort. Now let's look at an example problem. So we have here are x and y both positive. So statement 2 here says x over y is greater than 1. How do we evaluate this? Well, if we think about it from a logical perspective, we know that we can have x over y both be positive, where x is greater than y, and we're going to end up with x over y is greater than 1, right? 1 is a positive number, so we know that x over y must also be positive. But we can also make x over y positive if both of those values are negative, right? The two negatives are going to cancel each other out. So then, as long as x has a greater magnitude than y, we're still going to end up with a true statement. So we can use logic alone, not even thinking about actual numbers, to go through and go, okay, statement 2 is not sufficient on its own. However, if we can't work through that in our head, all is not lost. We can go through and pick numbers that logically would make the statement false. So if we read the question, are x and y both positive? We don't want to go in and pick values for x and y that are both positive, right? We want to maybe go in and pick values where x and y are not both positive. Maybe one where x is positive and y is not positive, right? Maybe an example where x and y are both negative. And then we're going to want to confirm by picking x and y both being positive. So we're going to want to pick values where we can get yes, x and y are both positive, and no, x and y are not both positive. If we can get both a yes and a no here, then we're going to determine that that statement is insufficient. So here we'd probably pick, let's see, 2 over 1 is greater than 1. Perfect. So that's x and y both being positive. And then let's try, okay, -1 for x, -2 for y. Okay. So then we end up with 1/2 is greater than 1. Well, that's not true. So that didn't work. But let's try x with a greater magnitude. Let's try x is -2 and y is -1. Notice that I'm choosing numbers that are very small and very easy to do in my head. So here we end up with 2 again. So 2 is greater than 1. That's true. So, but in this case, both x and y were negative. So in this case, we were able to determine that no, x and y can both be positive, and also x and y could not both be positive. So we got both a yes and a no. It's insufficient. So in this case, logic probably would have gotten us there faster, but picking numbers that we were pretty sure would create different scenarios can also get us to that answer. All right, and then the last strategy is more of an overarching theme, which is to guess on hard questions to save time. Now, in an ideal world, we would be able to solve every single problem, right? We would be able to go through and evaluate each statement, solve every single problem, get to exactly the answer we want, finish with time to spare. But this isn't what the quant section looks like for most people. There are going to be problems that you're going to take 5 minutes on and you're still not going to be sure on your answer. And then there are going to be problems where it's going to take you a little bit longer than it should, maybe 2 minutes and 20 seconds, but you can definitely get to that answer. We want to take that extra time and spend it on those kinds of problems, the ones that are going to more likely guarantee you a correct answer than the ones that are really, really hard and you're still not going to be sure even after all that time. So a really good strategy here is when you look at that problem going, this is going to be a waste of my time, I'm going to save that for something else. Now, in some cases, that's just going to be not evaluating any of those statements, just calling it a loss, making a guess, and moving on. But in some cases, we're going to be able to evaluate one of those statements, eliminate 2 or 3 of our answer choices, and then move on. Maybe it's just one of those statements that's too hard. But thinking about guessing as a strategy to help you out can help a lot on those data sufficiency questions. So always prioritizing your own time and staying aware of where you are in the test is one of the key elements on data sufficiency. So those are the 4 big data sufficiency questions, and that is the introduction to GMAT data sufficiency. So this covers the basic topics, an overview of the quant section, the structure of data sufficiency questions, what is the concept of sufficiency, what is the point of these questions, how do you approach them, and 4 key strategies. So that's the introduction. If you have any questions on what we talked about today or a suggestion for future videos, please leave us a comment below. You can also hit the button to subscribe for 3 new GMAT videos every month. You can also feel free to check out the PrepScholar GMAT blog for even more great GMAT content, and links for all of that are in the description. So thanks again for watching, and happy GMAT data sufficiency studies.